Hello, ladies and gentlemen. What we're going to take a look at today, we're going to take a look at terminating and repeating decimals. What are they, and how do we actually turn any of these fractions into decimals? So, the first thing we're going to do is we know that all fractions, they're just a division problem. That's all they really turn out to be. In this case, if I look at my first fraction up here, I notice that 2/5 is really 2 divided by 5. So, how do I convert that? If I don't have a calculator accessible to myself, how do I turn that into a fraction, or excuse me, a decimal? Well, I'm going to use long division. And because that was 2 divided by 5, I'm going to place that 5 on the outside of my long division and try and place it into 2. Now, what we already know is that 5 cannot go into 2 equally. So, 5 actually goes into 2 0 times equally. So what I have to use then is I then have to use a decimal, and my decimal will then match the same place as in my answer as I have down here in underneath my division problem. So from here, we actually could add on. This 2 could be written also as 2.0. And if I wanted to, I could continue that decimal place and really make it 2.0 for as long as it goes. It still always comes back to being just 2. These are just 0 that fill those places up there. So when I divide here, I'm just going to start with that first 0, and I'm going to see now, does 5 not go into 2, but does 5 go into 20? Well, 5 goes into 20. It actually does equally 4 times, and I know that 5 times 4 is 20 again. And therefore, I get down to 20 minus 20 is 0. And if I get down to the 0 right here, that tells me my decimal is complete. Therefore, 2/5 is actually equal to 0.4. Now, what that is right there, that is an example of a terminating decimal. And what a terminating decimal is, it's a decimal that actually ends in a 0. I'll write that down for you. A decimal that ends in a 0. And where is that 0? Well, technically down here, that's the 0 that it ended in. And realistically, I could rewrite this as 0.40 or 4 tenths or 40 hundredths. Those are all the same meaning of 2/5. So that is your example of a terminating decimal. Now I'm going to take a look at my next one. And take a look at 2/9. Let's see what happens here. I know that this is actually 2 divided by 9, so I'm going to write that in as a division problem. Long division, 9 into 2. Let's see what happens in this case. As we did in the first one, I know that 9 cannot go into 2, so I have to write a 0 above, and that tells me that I'm going to be dropping a decimal place for this 2. And we're going to write it as a 20 now, 2.0. And now I'm going to take 9 into 20. 9 goes into 20. Actually only goes into 20 twice equally, because we know 9 times 2 therefore is 18, and now I will subtract. So now in here I take 20, subtract 18, and I actually get 2 left over. Well, because this was not a 0 down here, I still have to go back and divide and put 9 into 2, but we know 9 can't go into 2. So as we said in the last problem, we're going to extend this decimal place back here, so I'm going to add another 0 to that 2 and drop it down. So now it's just going to be 9 into 20 again. This time 9 goes into 20. We know that goes in twice. And 9 times 2 is 18. I subtract again. And I get a remainder this time of 2. Let's try it one more time. I know because this is not a 0 yet, I have to drop and add another 0 all the way down here. So I'm taking 9 into 20, which we know goes twice. And again, 9 times 2 is 18. I subtract that 18. I get a remainder of 2 again. Now, what you should be noticing at this point, every time, if I kept adding a 0 up here every single time, my remainder always remains the same, which means I'm going to be dividing 20 by 9 every single time, which is every single time going to be a 2. That means what our actual decimal here is, 2/9 is actually a decimal of 0.2 repeating. And this is an example of what we like to call a repeating decimal. Here's what a repeating decimal is. It is a decimal that obviously repeats, but the specific part of this is it repeats actually in a pattern. And what do I mean it repeats in a pattern? Well, this is your pattern. Every time I keep dividing 2 by 9, I get a 2 repeating forever. That 2 keeps coming up every single time I go through and divide this. That is a pattern. I could have a different pattern. For example, there's sometimes that you could have a pattern as a decimal that would look like this. 0.181818. In that case, that is also a repeating decimal. That would be 0.18 repeating. That 1/8 repeats every single time I divided here. Okay? So, your last example, we're going to take a look at 3/7, and we are going to actually divide it. We're going to use long division, and we are going to figure out, is it a repeating or is it a terminating decimal? So, I'm going to take 7, I'm going to put it into 3, and I know it goes 0 times, so I'm going to place those decimal points up there, and we're going to see what happens. This time, 7 into 30, it actually goes 4 times. And I know 7 times 4 is 28, so there I'm going to subtract, and I get a remainder of 2. Now, because that wasn't a 0, I'm going to add a 0 up top to that 3 and drop it down. So now I'm taking 7 into 20, and we know that goes only twice because 7 times 2 is 14. I subtract, and I get a remainder of 6. Well, that's not a 0, so I continue. And by the way, I would keep going because I don't see a pattern yet. So 7 into 6, I can't do that, but I can do 7 into 60. 7 goes into 60 8 times because 7 times 8 is 56. I subtract, I get a remainder of 4. Well, I don't have a pattern yet. I don't have a 0, so I'm going to drop another 0 all the way down. And now 7 into 40, we know goes 5 times because 7 times 5 is 35. I get a remainder of 5. Well, not a 0. I don't see a pattern yet, so I'm going to drop another 0 all the way down, and I take 7 into 50, and I get 49. And I'm sorry, that 7 goes into 57 times, and by 7 times 7 gives me 49. So I get a remainder of 1. Unless I'm mistaken, I still don't see a pattern, so then I have to drop another 0 down here. And now I take 7 into 10. 7 into 10 only goes once. I subtract, and I get a 3. Well, not a 0. I still don't have a pattern, so I'm going to drop another 0. 7 into 30. That actually goes 4 times. Because we know 7 times 30 is, or excuse me, 7 times 4 is 28. I get a remainder of 2, which would mean I would drop another 0. So now I'm taking 7 into 20. 7 into 20 goes, we know twice, because that is, now we're subtracting 14. And wait a minute, I get a remainder of 6. Take a look. I just wanted to keep going with this to make sure we understood. What do you see here in this pattern? I actually do see a pattern starting to happen. 0.42857142. And if I follow, if I look all the way down here, when I got to 30, wasn't that just like 7 into 30? Our original problem, 7 into 3. We actually get back to the beginning, which our next number would most likely be, and actually is, with this 6. If I made that a 60, 7 into 60, we know goes 8 times. We know we actually stop and have a repeating decimal. And what repeats all the way down from 4 to 1? That is our repeating decimal in this case. So our answer would be 0.428, 571 repeating. So what you're going to do now, you're going to get working on the worksheet that was provided for you. You're going to figure out, are they terminating or repeating decimals just by using long division. And then you're going to define on the back what is a terminating and repeating decimal.